So welcome to Fly-by-Wire Control System. Let's just dive right in and find out what this is all about. So back to our trusted question, what's the least fun thing about this game right now? It's probably not the crazy physics. Think about Goat Simulator. That actually thrives on crazy physics. So does, what's it called? Who's Your Daddy in games like that. You don't necessarily have to get your game finished and polished in order for it to be highly successful, but it does need to stay fun. So I think the thing that needs dealing with now is two birds in one stone. Firstly, I don't necessarily want to have to drive my tank with the shoulder buttons and triggers. Interesting and direct as it is, I want to add the ability to use the left thumbstick on the controller, for example, in order to drive the tank, and possibly the standard WSAD key combination. And in order to do that, we're going to need to introduce a new layer of control, a fly-by-wire layer, that turns our intentions into actual dry track commands. Furthermore, we're going to need that in order for the other tanks, the enemy tanks, to be able to be driven by AI, because the AI will not be able to directly drive these tracks in the way that I'm kind of naturally doing now by choosing left and right and the appropriate mix of throttles. The AI is not going to be able to do that without some help. So let me explain this in a slide for you, what I plan to do. We start off with a human or AI intention. And the AI intention may be to move forward or to turn left or right or whatever. And the human intention would be very similar. Now, the things that you can do very specifically is you can ask to go clockwise at a speed between -1 and +1, where +1 clockwise is clockwise as fast as you can go, where a value of 0 coming out of this layer is do nothing, and a value of -1 is go anti-clockwise as fast as you can go. And the other thing that you could do is you could say, I want to go forward on the same basis, or of course backwards. So how does that relate to a controller? There's an Xbox controller for you. Well, if you want to go forward, you could take the left thumbstick, for example, and you could push forward in order to go forward at full speed and back to go backwards. Pretty simple. If you want to rotate clockwise, that could be interpreted as moving the stick left and right. And of course, there could be any mix of those two. I could say I want to go mainly forward, but turn right a little bit as I do so, etc. So that would feel, I think, very natural, that control system. And it's also a control system that if the AI was to put its robotic hands on this controller, it would actually be able to control the tank too, because it's an API that the AI could use. So that's the clever thing about abstracting the control like this. So in order to make this work, we need a fly-by-wire layer. We're going to call it a tank movement component. We're going to make that in a bit. But it's a fly-by-wire layer. What that means in an aircraft, fly-by-wire means that you don't directly control the control surfaces anymore, but that you put a control input in, and the fly-by-wire system works out what your intention is, so pulling back on the stick is I intend to pitch upwards, and then it does what it needs to do with the control systems in order to make that intention come true. And that's what's happening with this fly-by-wire system here. How does it do it? Well, it's very simple, actually. It only needs to spit out two values, right? +1 and -1 to the left track, and +1 to -1 to the right track. That's all it can do. And by organizing things like this, the cool thing is we can be sure that the AI also has exactly the same controls as we do. It's literally like it's a robot holding the controller. And in a lot of games, and including in Unreal if we're not careful, you will find that the AI moves very differently to the human players in some games. What can tend to happen is that the AI may steer the tank kinematically, for example. It may just move its position without any respect for the physics. We don't want that. And if we just use Unreal's pathfinding and AI out the box, that's what would happen. But we want to restrict the AI to the same control system and the same type of tank as us. It makes the game much more fair, much more fun. And it's a very useful technique to know about. But I want to go one step further because I'm ambitious with this, and I want to make sure that we can mix in our control inputs from the right and left shoulder buttons and triggers. Now, I'm not showing all of the lines because that would just mess up the diagram. But the point is that I could choose to control the tank by using the left thumbstick, or I could immediately let go of the left thumbstick and start using the shoulder buttons, stroke, triggers. And either way, the movement would work on my player tank. The AI, of course, is constrained to talking to the fly-by-wire system. So we're going to end up with a dual control mapping, one that goes into the fly-by-wire system from the left thumbstick, and another control mapping, which we already have, which goes from all the shoulder buttons and triggers directly into the tracks. And we're going to show how to make sure that we can mix these things without doubling up, to make sure that if you say pull both triggers in for maximum forward speed, and then push the left stick forward, what would happen then? Well, it shouldn't be going faster than its maximum speed. So we'll learn all these tricks, which will allow you to make games where you have very rich control systems, where you can allow the player to have some freedom to do things in more than one way, even at the same time. So I hope that sounds exciting for you. So that's the idea. Right, so for the rest of this video, we're just going to talk about this C++ class and what it's going to be based on, because we need to think a little bit carefully about what we're going to base our tank movement component on. So we are going to create a new C++ class. And it isn't going to be any of the standard ones in the list, I'm afraid, because there isn't anything that's quite right. So we're going to go to Show All Classes. Now, how would you find this the first time for yourself? Well, you want a movement component, so you might want to start typing that, movement, and you get a whole bunch of stuff. And you can see the hierarchy here. It's the top of this list we want, the actor movement components. So an actor component clearly isn't enough, just adding an empty component. A movement component, well, what does that do for us? Well, it's an abstract component class that defines functionality for moving primitive components every tick. Okay, that's fine. It's not quite enough. So let's keep going. Nav movement. Okay, that defines functionality of the movement component that moves any agent that may be involved in AI pathfinding. So what is AI pathfinding? It's artificial intelligence agents in the game finding a path from where they are to you. So we've got a big old hill in the middle of our landscape, right? Let's just take a look at it. That lump in the middle here, and I hope that you've got some sort of obstruction in your landscape. It makes it more fun. If you haven't, add something like this hill. And what the idea is if an AI tank was to start the other side of the hill from us, it will work its way round the hill if the hill is seen as an obstruction. So we want to be doing pathfinding, and this can be done automatically by Unreal, and it's very cool. All right, so that is the reason that we're going at least that deep into the hierarchy. Let's go back. Let's type movement. And let's keep going. Now, is nav I'll put my teeth back in and try again. Is nav movement component enough, or do we need a pawn movement component? It also provides ways to accumulate and read directional input in a generic way. Add input vector, consume input vector. Possibly. We could possibly need as much as a pawn movement component, but why don't we start with the simplest thing we can? If we're going to allow the AI tanks to do pathfinding, the simplest movement component that we can use, bearing in mind that every time we go down this tree, we get more stuff added on, more complexity added on, is going to be a nav movement component. And that will come with the pathfinding tools that we need, and then are going to butcher in order to make these AI tanks behave. So, a lot of talking to tell you to ultimately make yourself a new class based on the nav movement component, and let's call it tank movement component. There we go. All right, so hopefully you understand the reasoning for that. We're going to be doing a lot more work inside the tank movement component, of course, once we get into the next video, where we will start to set up the actual fly-by-wire system. But for now, your job, we don't need a challenge slide in this video, it's just a lot of explanation of what's to come. But your job is just to make sure that you have this tank movement component like so, and that it's based on a nav movement component, and that your code still compiles, and that your game still plays as it used to. Obviously, there's going to be no difference in behavior because we've just added an empty C++ class. So congratulations on watching this video. I hope you've enjoyed it. I hope this fly-by-wire malarkey makes sense. That is an overview of what we're doing. I'll just strip off the... Oh no, I'll leave the controller on. I'll leave that on the screen for you so you can digest what we're doing and why we're doing it. And I will see you in the next video.